So the next thing here that they actually took into account was the model scaling techniques. So one of the main advantages with YOLO V7 is that we get them in different kind of like sizes. We get like a series of models. So we have the nano model, small model, large models, and so on. So this is actually like released in a series of models where we're scaling them up and down based on the number of parameters and so on. So this is really good because we have different applications where we want to deploy these models. And they require like different levels of accuracy and also inference speed. So maybe we don't want like as high accuracy where we more focus on the inference speed, and sometimes we just want as high accuracy as possible and we don't really care about the inference speed. So we need some model scaling techniques for that. And then over here to the right is the one that they're using in this model here. So they have this compound scaling up depth and width for concatenation based model. So typically in object detection models, we consider like the depth of the network, the width of the network, and also the resolution that the network is trained on. So we have like the width, so the number of like channels or like layers that we have in our network. We also have like the width, so how many like feature maps and all these different kind of things do we actually like have in the width as well. So we'll have the width of the neural network, and we also have the depth, so how many layers are we actually like concatenating together. And then we're also talking about like the resolution of the network that is trained on, like the image resolution, for example. So here in this paper here for the YOLO V7, they think about like scaling the network depth and the width in concert while actually like concatenating the layers together. So they're both scaling at the same time in the width and also in the depth, and then they just concatenate those layers together. And then this technique here, it just keeps the model architecture optimal here while scaling for different sizes, and that is why it's really good to use this technique in, for example, like YOLO V7, because they have these different kind of like types of model where like they both scale them up and they scale them down for like different applications for accuracy and inference. So that will be a trade-off of accuracy and speed, inference speed. But this is a really nice technique to actually like scale up your models both in width and depth without really like losing like accuracy. And then you just like you basically just like, if you're not using this technique and you just try to like upscale your model as much as possible, you just want to have a model that is really large and has a lot of parameters. You just want the highest accuracy as possible. But then again, if you just scale them without taking these things here into account, it will just be like impossible to do inference on. It will just take too long to actually like be able to run these YOLO V7 models here in a reasonable time. And the idea behind the YOLO models is actually like that. We just pass in an image, we get an output, and we should actually like be able to run these models here fairly fast and also in real-time applications.